2006. How many significant figures? 2006. How many significant figures are there? How many significant figures are there? 2006. 2006. So the statement is clear. All zeros in between non-zero digits are significant. Okay. Then suppose we have number 1200. 1200. How many significant figures?
Two.
That means the last zeros, they are what? Trailing zeros. The last zeros are not significant. Last zeros are not significant. If there is no decimal involved in the number, then the trailing zeros are not significant. Means if there is a number 1320, 1320. Okay. How many significant figures are there?
Three.
1320. The last zero is insignificant. Okay. Suppose the number is 12,000. So what is significant figure?
2.
12.
1.
How much?
2.
2. Suppose 14,000.
2.
15,000.
2.
21,000.
2.
6,280.
3.
8,000.
1.
That means what? The last zero, if there is no decimal involved, then the last zero is insignificant. That must be left. Okay. So three statements we have given now. All non-zero digits are significant. Number 1. Number 2. All the zeros in between the non-zero digits are significant. Next, all the trailing zeros are not significant. Then what about decimal number? If decimal is there, till now we have discussed when there is no decimal. But suppose there is decimal. Okay. Suppose there is decimal. If the number is 12.000, if the number is 12.000, then how many figures are there?
5.
How many? 12.000.
5.
That means, for the statement, if there is a decimal number, then the trailing zeros are significant. Trailing zeros means the zeros which are coming towards the end. Trailing zeros means the zeros which are coming towards the end. 23.0. How many significant figures are there?
3.
23.0. How many? 3. 2.30.
4.
3. 2.30.
3.
2.0.
2.
1.0. 6.0,
2.
6.002,
4.
0.002.
4.
4.
How many?
4.
So what is the point? If that 0 is in between non-zero digits, it is significant. If the 0 is towards the end and there is no decimal point, then they are not significant. If there is decimal point and there are trailing zeros, they are significant. Now, if the number is less than 1, when the number is less than 1, we start with 0 point something, isn't it? So when 0 point something is there, let us say 0.2. How many significant figures?
2.
No, only one. 0.002.
2.
No, only one. Here, whenever the number is less
Yeah.
number, whenever the number is less than 1, we'll have to write 0 point something. When we are writing 0 point something, after the decimal, now the number is with 0 point something. Suppose 0.002. Then the decimal point and the beginning zeros after the decimal point. Beginning zeros after the decimal point till we get a non-zero digit. They are not significant. What the point? 0.002. How many significant figures?
1, sir.
Only one. 0.0056.
2.
2. 0.000030. 2. Because 3 is significant and the 0 after 3 is also significant. Is that okay?
Yes, sir.
Yes, sir.
Everybody? All the rules are clear?
Yes,
First
sir.
one we said, first one, all non-zero digits are significant. Number 2, all the zeros in between non-zero digits are significant. Number 3, all the trailing zeros when there is no decimal number are not significant. All the trailing zeros, if there is a decimal, are significant. If the number is less than 1, then the zeros, number of zeros, all the zeros in between the decimal point and the first non-zero digit are insignificant or not significant. Is that okay? Suppose the number is 0.002500.
4.
0.0020500.
5.
5.
5.
5.
It's 2050. Total
5.
figures. Okay? That is clear?
Yes, sir.
So how to count the significant figures is clear to all of you?
Yes, sir.
Yes? Now, how we perform the addition, subtraction, and what is rounding off? First of all, what is rounding off? What are the rules of rounding off? When you are rounding off, suppose 23.86. Suppose it is rounded off to 3 digits. 23.86. It is to be rounded to only 3 digits. If it is to be rounded to 3 digits, the last digit is 6 and 6 is greater than 5. So when you are leaving that last digit which is greater than 5, in that case, one should increase, the previous number should be increased by 1 unit. Okay? Clear? That means 23.86 rounded up to 3 digits. What will you get? 23.9. Okay. Suppose it is 23.85. So when it is last digit is 5 and that 5 is to be dropped, then you have to check whether the previous number is odd or even. If it is even, then you can simply drop 5. So 23.85 drop, change to 3 digits or rounded up to 3 digits. That will give you 23.8 only. Whereas if it is 23.55 or 23.35, that means the last digit you are going to drop, but the previous digit is odd. If that is odd, then you should add 1 to the previous digit and then drop 5. That means 23.35 when rounded up to 3 digits should become 23.4. Suppose the number is 23.75. Then after rounding up it will become 23.8. Okay, it will become 23.8. Is that okay? Now see, suppose the number is 431.63. 431.63. And it is to be rounded up to 4 digits only. So the last digit to be dropped is 3, which is less than 5. If the number is less than 5, you can simply drop it. It will become 431.6.
6.
Okay? 431.6. But if it is suppose it is 431.68 and here it is to be rounded up to 4 digits, then what is the answer? 431.7. So what are the rules of rounding off? If the number to be dropped, last digit to be dropped is less than 5, you simply drop it. If it is more than 5, add 1 to the previous digit. If it is exactly 5, then see the previous digit. If it is even, then drop 5. If it is odd, add 1 to the previous digit and then drop 5. So rounding up here. Everybody? So significant figures and rounding up. Now we go to addition, subtraction, multiplication and division with significant figures. And thereafter we will go to errors. Now, suppose we want to add 3 digits, 3 numbers. Okay. Suppose we want to add 3 numbers, and the numbers are like this. Let us say 26.83, 436.567, 1.37. So these are to be added with due regard to significant figure. These are to be added with due regard to significant figures. Okay? Due regard to significant figures. If we are asked to add, what is the procedure? The procedure is check the number of digits after the decimal. Check the number of digits after the decimal. Okay? That's clear? Now, here after the decimal 2 digits are there. Here after the decimal 4 digits are there. And here after the decimal 3 digits are there. So in which case least number of digits are present after the decimal? In which case least number of digits are present after the decimal?
First case, sir.
First case, because after that only 2 digits are there. So remember, in the final answer also there must be only 2 digits. So sometimes in the question you will find there is only one option which 2 digits after the decimal. So if you are smart enough, then you can directly go to the answer. Provided there is only one option with 2 decimals, like 2 digits. With only one option after the 4 containing 2 digits after the decimal, then you can be sure that that is the answer. You need not do anything. It's the fastest method. But suppose there are more than one option which is containing 2 digits after the decimal, then you have to calculate. Procedure first identify the number having least number of digits, then round off the other numbers in such a way that after the decimal there is one extra than this. That means here there are 2 digits, right? Here there are 2 digits. So in the remaining numbers there must be 3 digits. That is the idea. So here there are 4 digits, 5, 6, 7, 4. So one digit is to be dropped. And because this is less than 5, you can simply drop. So you can simply drop that digit. And here these are having 3 digits. So that's what is required. Because every number should contain more digits than the least number of digits after the decimal. Okay. Now after doing this, you add. So you add what you get. This is 9. What is this? Is that okay? Check column. Is this correct? Addition is correct?
Yes, sir.
Yes, sir.
Yes, sir.
After doing this addition, what I have to do is again round off so that because after the decimal there are only 2 digits, so there must be only 2 digits after the decimal. That means now we are going to drop this. But this is greater than 5. So the answer will be 464.77. Have you understood?
Yeah.
How to add new regard to significant figure? Is that clear? How to? The question is given on addition. you got the significant figures. You can do that. Remember, for addition and subtraction, the procedure is same. For addition and subtraction, the procedure is same. The same procedure now for subtraction also. If two quantities are to be subtracted, then the final answer must be containing the number of digits after the decimal as are contained in the minimum number of digits. Okay. Here the minimum number of digits after the decimal is 2. So the answer must contain only 2 digits after the decimal. Is this clear? In subtraction also, procedure is exactly the same. Now we go to multiplication and division. See, for addition and subtraction, this is the rule. But for multiplication and division, that would be different. Suppose 2.1 6.7 divided by 3.12. If the number is given like this, remember the procedure is you multiply these two, okay, and divide by this. Multiply this, divide by this, and finally what will you do? You see there are 3 numbers, 1, 2, 3 involved in the operation. In the operation, there are 3 numbers, 1, 2, and 3. This is containing least number of significant figures. Here the number of significant figure is 2. Here the number of significant figure is 3. Here the number of significant figure is 4. Isn't it? So after doing all the calculation, you will get some number, but that number you round off. Okay, you round off that number to only 2 digits. Here also, if options are contained, if there is only one option which is containing 2 digits, then that is answer. Is that clear? Here we are not seeing the number of digits after the decimal. Here we have to see the total. Each number is having least digit, least significant figures. Here this is having least significant figures, that is 2 digits. This 2 digits, final answer should contain only 2 digits. So, if you observe here, it is approximately 300. This is approximately